Hey everyone, so today we're going to talk about average rate of change and the definition of a derivative. Okay, so average rate of change, which you may hear referred to as AROC or AROC. AP won't do that, but you just might hear us say it as a quicker route. Average rate of change is really, again, just another way actually to call slope, or kind of that classic Algebra 1 slope. Okay, so let's say we have points A and B. So that would give us f of A, some value here, and then f of B, some value right here. Okay, so if we were given a graph like this, and I asked you to find the average rate of change, here's really what we're looking for. We're going to be looking at the line, or the slope of the line that connects these 2 points. This is also called a secant line. If you guys remember from geometry, secant lines cross twice. Tangent lines touch the function just once. Okay, so again, another way you're really definitely going to hear this, slope of a secant line. Okay, and I could ask you that way, find the slope of a secant line between A and B. Or I could say find the average rate of change. Okay, no matter what though, it's kind of this change in y over change in x. So it'd be f of b minus f of a over b minus a. Again, change in y over the change in x. Okay, and like I said, we'll talk more about average velocity and position. One other thing you want to notice here is it approximates the derivative if we don't know anything about the function, and we'll talk about that more in a later example. Okay, so again, you might have done some of this last year, talked about tangent lines, derivatives, shortcuts. We're going to kind of start at 0, which is, pretending we haven't heard anything about it. So slope of a tangent line, okay. There's many definitions here, and you can see I kind of filled in most of them for you. The biggest situations you need to understand are, first of all, the definition of a derivative. Okay, if we're talking about the derivative at some point, we're talking about a tangent line. And again, a tangent line is something that crosses or touches at one value. So, example here, that would be at, this line would be tangent. This is, again, called a secant. And what our goal is here is we're going to be talking about different ways to find that derivative and using limits to get there. So I want to point out a couple things here. There's a few definitions we need to know. So first of all, I have this one highlighted. This one's really important. Okay, let's write this one down. Well, it's written down for you, but let's highlight it. And that's going to actually be this picture. I'm sorry, I reversed the number 1, number 2. So f prime of a, okay, that's again a different way to say a derivative. So f prime of a, the derivative of f at point A. Again, this is some value. The limit as x approaches a of f of x minus f of a over x minus a. Now you might notice this looks a lot like average rate of change, except we've got this limit in front, okay? Now here's what's going on with this, okay? If I have a, and if I have this value over here, okay, f of x, and I first, I have f of x and f of a, and I'm calculating here, but I want to know what happens as x approaches a. So what happens as x gets really, really close, right? So then maybe x is moved to here. Okay, now I have a closer approximation of a tangent line. What if x is right here? Closer approximation. Really the best approximation is when x is so infinitely close to a that you guys, I'll erase a little bit here. You guys can see this pink line here is that tangent line. Okay, you'll see a tangent line here. These are secant lines that are getting closer and closer and closer to the tangent. But I hope you guys notice if I were to plug in, okay, as x approached a, what if I plugged in a? What would happen? I would get 0 over 0. So we're just talking about as it gets infinitely closer, but not necessarily plugging in a. Okay, another definition you're going to need to know, it could be this version, more popular you'll see if we're just talking about what about the derivative in general, maybe not at a value, but if I just say, what's the derivative of f of x? Okay, that's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, now you'll notice this is very similar, but I'm talking about f prime of a. So again, I'm talking at a certain value. This is the one I typically prefer for a certain x value. right? You want to know f prime at an x value. This one is usually used for a general derivative. So if you just need to find the derivative of f of x in general with not any x values specified. Again, I know there's a lot of definitions here. I'll kind of organize what's going on. This definition right here, okay, I'll highlight in yellow. That guy is going with this Google link right here. So we're going to see in a second what these look like kind of more visually. Here's what's going on. The only difference with that x plus h business and h approaching 0, here's what I want you to imagine. This is like as though we had x here, okay, and then I added some h, maybe it's 2. So I'm 2, or 4 units away here. Okay, what if h is only 3? Well, then I'd move closer. What if h was 2? I'd move even closer. If I got h all the way down to 0, where it's basically x, right? X plus 0. If I approach really, really, really close, again, that's where I'm getting this pink tangent line. Okay, so that's the only difference there. Again, this definition here, I'll rewrite them for you guys, is f prime of a, okay, is equal to the limit as x approaches a of f of x minus f of a over x minus a. In this one, we're talking more general. F prime of x is equal to the limit as h approaches 0. So like I said, that little h value, as it gets really, really close to not existing, where it's just equal to x, of f of x plus h minus f of x over h. Okay, so write those two down, pause if you need to. I think this is the best way of looking at it. I want to show you these two Google links just to show you kind of what I'm trying to show without in a little more active movement. So take a look here. This is the first definition with as x approaches a. Okay, so as my x value, let's say it's up here. Okay, there's my secant line, that average rate of change. As I get closer and closer and closer to a, so again, as x approaches a, what's happening right about here, right? You can see right when I overlap with that point, I'm at that perfect tangent line. Okay, if I go too far the other way, I get a secant line. I want to know as x is equal to a, right there. Okay, what's that slope of the tangent line? Versus if I have f of x plus h, so you'll see if I move h closer to 0, closer and closer and closer to 0, I'm getting really close, and then boom, I'm right at, right at about a. So as h approached it, and h went, look at that 0.01, that's the closest approximation I can do by hand here. We're gonna actually take those limits and use them. So again, let's go to the notes. One thing I want you guys to know about these different ways of saying it, and this comes up a lot, is all these things mean find the derivative f prime, f prime, f prime, but you might see it in different ways. So one way you might just say is derivative. You might hear slope of a curve at x equals a. So again, if it says slope at a certain point, we're assuming it is that derivative. Slope of the tangent line. Remember, secant line was AROC, right? Secant line was average rate of change. Tangent line, we're talking derivative here. And instantaneous rate of change is another way you might see it. And it also could just say rate of change. Okay, again, this is rate of change. If you see that word average rate of change, that's flying back up here to AROC, okay? So again, we're gonna be talking more about this. Since it is the slope, you'll see like tiny little dashes here. F prime is 0. What's the slope at 0? Well, it's pretty positive, right? It's a 96. Is the slope 64, 32? Okay, when I'm at the top here, I'm at a slope of 0. What happens as the slope is turning? Negative 32, negative 64. So we're going to be working a lot more with this graphically, but just an idea. And again, you've got that instantaneous rate of change, derivative, all these different meanings. All right, so let's take a look at actually solving some of these. So number 1 says f of x is negative 3x plus 5. Find the average rate of change. That was AROC. Again, remember, that's f of b minus f of a over b minus a. Okay, and in this case, a and b are negative 1 and 5. So f of 5 minus f of negative 1 over 5 minus negative 1. What does that give us, guys? That gives us f of 5. If you plug in 5 here, that gives me negative 10. If I plug in negative 1, that gives me 8. 5 minus negative 1 is 6. And I get negative 3. So my average rate of change from negative 1 to 5, or the slope of that secant from negative 1 to 5, is negative 3. Hopefully this isn't too shocking to you because you know what this graph looks like maybe. Okay, so now we're going to jump into another one, which is finding f prime of x. Again, it doesn't say at a certain value, so what we're going to be using is that first definition, or I think I listed it as actually the second definition, but either way, let's write it down. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and you will need to recognize these definitions. I know you might know some shortcuts of how to find the derivative, and I promise you we're going to get there in a few days. But I definitely, these do come up on the AP exam where they're written as the definition of a derivative with this limit. So I just want to make sure we're familiar with that. So let's actually try finding this here. Remember, f of x plus h, that just means instead of x, so let's write these on the side here, we can just calculate them. F of x plus h would be negative 3 x plus h plus 5. Okay, and then f of x, of course, is just negative 3x plus 5. Okay, and those are the things we're plugging in here. So I'm going to take this. So this is equal to the limit as h approaches 0 of negative 3 times x plus h plus 5 minus, notice my parentheses here, negative 3x plus 5. All divided by h. Now, you might be thinking we could just plug h right in as 0, but what would happen, guys? We'd have that denominator of 0. So that won't work for us. We're going to try simplifying, and this should work out really nicely for us. Okay, so this gets us negative 3x minus 3h plus 5. Okay, distribute my negative, I get plus 3x minus 5. Okay, organize these all together. Add these together. What do we got? Negative 3x and 3x cancel. Plus 5, negative 5 cancels. So I end up with this. The limit as h approaches 0 of negative 3h over h. Well, h's cancel. What's the limit as h approaches 0 of negative 3? It's just negative 3. Okay, so if you do these correctly, and it's not too bad of a function, typically this will be really nice, and x's will cancel out, or even if they don't cancel out, there'll be some type of simplification that makes this solvable for us. It makes it a nice function that we can see. So that is finding the, again, I use that first definition here because I'm just looking for the general derivative. But now if I'm talking about a derivative at some certain value, okay, I might be using, if I'm looking for f prime of 2, okay, that could be using the other definition. Now, I want to point out here, okay, once you already found f prime of x, I can just plug x in here, but it's always negative 3 throughout the entire function. So it's not like we can even plug in x here. It's just no matter what, at x equals 2, x equals 4, x equals 7, we get back negative 3 as our derivative. So if it says write the line tangent, okay, kind of flashback to algebra 1 here, we're going to use point slope form. So y minus y1 equals x times x minus x1. Excuse me, m times x minus x1. Sorry if I misspoke. Okay, we're going to plug in a point for x1, y1, and our point will be a comma f of a, or whatever the value is, you know, x comma y at a, which is going to be 2. And the slope here, we know this, guys, this is going to be what's f prime of a. What's the slope at a? Okay, so let's think about the things we can plug in already. All right, so I want to know basically what is, I'll switch to light blue here. A is just whatever this is. So a is equal to 2. Okay, f of a just means, all right, go back to our function, negative 3 times 2 plus 5, which is negative 1. All right, and last but not least, f prime of a, again, which is f prime of 2. It's this right here. It's -3 everywhere. So literally just -3. If it was -3x or -3x plus 2 as your derivative, then we would plug in x and solve, but there's nothing to plug in here. So we're going to try this out. We've got y minus y1, which again is the y value, so y plus 1, equals the slope, -3, times x minus 2. Okay, so again, here's an easier way to think of it. You find the slope, and then you just need an xy point, which ours was 2, -1, was x comma y. Okay, because I had x given, and then I just plugged it in to find the y value. All right, and this right here is that algebra 1 piece. Plug in x comma y, and this is the slope. All right, part D is a repeat. Yay, it says the same thing, so we're skipping that. Okay, we're just going to try number 2, and then I think we're going to wrap it up here with just talking about the end of this derivatives, what we're going to finish in class, etc. So take a look at number 2. Okay, number 2, we've got given y equals x squared minus 2x. Find the derivative at -3. Now, I wasn't asked just general, what's the derivative? I'm asked at a certain point. So here's what I'm going to use for that. Okay, if I'm given specifically what's happening at -3, and maybe I'll just write this in general for a second, at some value of a, I'm going to use that first definition that is limit as x approaches a of f of x minus f of a over x minus a. So in this case, y prime of 3, excuse me, -3, would be the limit as x approaches -3 of f of x minus, I'm sorry, I should be using y. I'm erasing. I want to be better about that on this, my bad. Y of x minus y of -3 over x minus -3. All right, guys, so let's, on the side here, we could just figure out what is y of -3, right? We need to know what this is, so let's just do it over here. Y of -3, I'm just plugging in right here, -3 squared minus 2 times -3, 9 plus 6, I get back 15. All right, so let's kind of plug in what we've got here, finish up this problem. Okay, so I've got the limit as x approaches -3 of y of x. So simply I'm just plugging in this, replacing it right here. So x squared minus 2x minus, switch colors here. In yellow, I've got y of -3, which we decided was 15. So minus 15 all over x plus 3. Okay, you could try plugging in -3 here. I mean, that should have been the first move we made. Obviously, you guys know if you try it right now, you get 0 over 0. So we're going to have to do some algebraic manipulation here. So for example, we can factor the top to x minus 5, x plus 3. Those guys end up canceling. And now I've just got what happens as we approach -3 for x minus 5. -3 minus 5 is -8. Final answer. Now I want to clarify something here. One thing I want to tell you guys is, do you have to use this definition? No. Technically, over here I'll write in light blue, you could have used this definition of the limit as h approaches 0 of y of x plus h minus y of x all over h, which would have been, as h approached 0, I would have had y of -3 plus h minus y of -3 all over h. This doesn't look that bad, but right here what you're going to have to do is -3 plus h squared, remember the function, x squared minus 2x, minus 2 times -3 plus h minus blah, blah, blah. I mean, this gets so ugly here, guys. I'll put a note, lots of work. So if we have a value, right, so if we're looking at specifically -3, I really recommend you use this equation, which again is that limit definition derivative definition that has the limit as x approaches some specific value. Okay, this will work, it's just a little bit tedious. Okay, we're gonna save number 3 for class, so hold on to that. I do want to mention, and number 4, I do want to mention number 5 just briefly. And you'll notice the last page, by the way, I just have, here are many ways to say f of x, or the derivative of f of x, excuse me. So I just wanted to show you that. We'll talk about it more. Number 5, okay, last thing we'll talk about here, determine what the function is and what the value of x is. Here's what I'm trying to get you guys to think of. You have 2 definitions, right? The limit as h approaches 0 of f of x plus h minus f of x over h. And you also have, and this could also be a plus h and a. So it just depends if you're plugging in a value. And you also have, as x approaches a, f of x minus f of a over x minus a. So here's what I need from you guys. What's f of x and what is a? Okay, so take a look at this first one. All right, here's what I'm seeing. I see h approaches 0, so now I know I'm working with this definition. I'm looking for what this one looks like. So a is plugged in, right? Because this doesn't say x, it says x plus h, but it says pi over 2 plus h. Well, if a was replaced with pi over 2, I know that's the value I'm looking at. So a is equal to pi over 2. Now, what is that f of x function? Okay, f of x would be kind of that outer function. What did I plug in a plus h to? It would actually just be sine of x. So f of x is just sine of x. And this should make sense to us, because if I said sine of a plus h, sine of pi plus h, minus what would be next? Sine of a, or sine of pi over 2, which is 1, divided by h. So this is actually your final answer. I'm looking for what was the a value and what was the function. Kind of thinking backwards here, guys. This could be a classic AP multiple choice for you. Okay, we'll try one more and then we'll look at these in class. So take a look at this second problem here, x approaching e squared. Now, x is approaching a value. That's got to be this guy. So I'm looking at this definition. This one's a little easier to pick out because I need a. Well, a is just whatever this is. And then f of x is natural log of x. And now I have f of x minus, this would have been natural log of e squared, which we know is 2, over x minus a, which is e squared. Okay, so again, final answer is here's your a value, here's the function. I know these are a little strange and it's hard to pull out those functions, but it is kind of a nice trick to know backwards, and that will be something that we're working on. So yeah, thank you so much for watching. Again, look down here for kind of all those varieties of saying derivative. There are a lot of ways that we ask for derivatives, which I do think makes it a challenge, but you guys will be great at this. We're going to keep working on it. Please bring in any questions or type them into the video prompt. And again, thanks for watching.